Well, hello and welcome to our Safety Connection on the crucial role of lighting in workplace safety. This is a joint pre-recorded session between the Ministry of Labor, Immigration, Training and Skills Development, Public Services Health and Safety Association, and Workplace Safety and Prevention Services. Our presenters today are myself, Nathan Birch, a specialized consultant in ergonomics with Workplace Safety Prevention Services.
And myself, Lisa Hooper, the provincial ergonomist with the Ministry of Labor, Immigration, Training and Skills Development.
And I'm Stephen Fletcher, health and safety consultant for the Public Services Health and Safety Association.
So our agenda for the session, Module 1, we will discuss some key lighting and vision concepts where we'll just kind of set the foundation for the session to help us understand terminology, language, and concepts that will be important to the rest of the conversation. And then we'll get into Module 2, which will discuss lighting and workplace health and safety, kind of the meat and potatoes of the session today, where we will discuss the health effects of lighting, so how lighting can impact our health, as well as workplace health and safety hazards. And we'll round it out by applying the RACE methodology to recognize, assess, control, and evaluate with regards to workplace lighting conditions.
We thought that we would open the webinar with some examples that highlight the connection between lighting and health and safety. In this example, in a warehouse, the lighting fixtures create a high point source of sort of luminous output, very bright, presumably to provide sufficient lighting or illuminance to see and read information on the packaging stored up in the racking. Being a warehouse with blind corners, dome mirrors were used to reduce the potential for collisions or struck by occurrences. However, in this case, the hanging height of the mirror in relation to this intense light fixture resulted in the forklift operators being exposed to direct glare when the sight line to the mirror was aligned with one of the light fixtures. The intense light glare interfered with the operator's ability to see the reflected images on the mirror, and the mirror's potential benefit was essentially negated, and with increasing the likelihood for collisions because of that lighting interaction.
Perfect, thanks, Lisa. So another example of a poor lighting condition that can contribute to some concerns and issues. We look at this example of a warehousing type environment or storage area where many items are accessed and it's very dark. We see a poor lighting condition here, so it may be difficult to access items, see items. So we may actually get some items falling on the floor where we don't actually see them, and we might end up in a slip, trip, and fall situation. We could have glare. We see the example at the end of the aisle with a light source, a bright light source kind of pointing down. So that could cause some issues as far as that transition from a dark environment to a very bright light source, and glare associated with that and discomfort. We might get some injury related to some collisions or something like that if other workers are in the environment. We can't necessarily see when someone is there, or we bump into each other or the cart itself, and we might get into a contusion sort of situation, or again, a slip, trip, and fall. And then the impact to quality and productivity. So if we have this situation where there's poor lighting, where we can't actually see the labels, we can't actually see what the contents of the boxes might be, we're going to get some productivity concerns there, where it's going to take us a lot longer to actually find what we need, and ending up with some productivity concerns. Quality on the same side as well. It could be that we can't actually see what we're looking for. We pick a wrong item, we drop items and damage them, and that sort of thing. So a lot of effects when it comes to lighting. And over to Steve.
You'll notice in this picture of a workplace reception area that the room is lit, but the area directly where you would talk to a person at the counter is under a shadow. How would you fix this? If you improve the area behind the counter with task lighting, the worker would have a more conducive area, lit to an appropriate level. The area where a visitor stands could also benefit from the task lighting. So what I would do is put in some task lighting, and I would evaluate it with the people that work there, and I would also, from time to time, consider the people that are visiting and if they can see things appropriately. Understanding lighting concepts is essential because proper lighting enhances visibility, supports visual comfort, and improves safety and productivity in both work and everyday environments. Thoughtful lighting designs help reduce eye strain, prevent accidents, create spaces that are both functional and aesthetically pleasing. All lighting is not created equal. Certain lighting, whether it be natural or artificial, can serve a specific purpose. Lighting plays a crucial role in how we experience a space, from setting the mood to ensuring safety. Different types of lighting serve different purposes. Let's explore 6 key types of lighting: ambient, task, natural, overhead, emergency, and accent. Ambient lighting is a general illumination that fills a room. It provides overall lighting that allows people to move around safely and comfortably. Think of ceiling fixtures, chandeliers, or wall mount lightings. It sets the tone for the entire space. Task lighting is focused lighting used for specific activities like reading, cooking, or working. Desk lamps, under cabinet lights, and vanity lights are all examples. This type of lighting helps reduce eye strain and increases productivity. Natural lighting comes from the sun. It's not only energy efficient, but also enhances our mood and well-being. Skylights, large windows, and glass doors are all ways to invite natural light into the workplace. Overhead lighting is designed for durability and function. You'll often see it in factories, warehouses, or loft-style homes. It's typically bright, robust, and built to withstand heavy use and harsh environments. It could be a warehouse or factory floor lit with metal fixtures and exposed bulbs. Emergency lighting activates when the main power fails. It's vital for safety, guiding people to exits and helping prevent accidents during emergencies. Exit signs, backup lights, and pathway lights are common forms. You could be used for an escape route, an open area, an anti-panic area, and high-risk areas.
So some important concepts to help us understand exactly what we're talking about when we sort of discover common concerns and hazards and issues with lighting. We need to understand some of this terminology as well. So we'll discuss the difference between luminance and illuminance, different types of glare, contrast, shadow, and light distribution or uniformity. So to help us understand the difference between luminance and illuminance, this visual on the right kind of helps with that. We think of luminance as the amount of light emitted, passed through, or reflected from an object. So we think of that light fixture emitting the light, and that's what we are referring to with luminance. Generally measured in candela per square meter, and illuminance is the amount of light falling on a surface, as you see represented as that light casting on that surface in the image to the right. So it's generally measured in foot candles or lux. And generally when we talk about the workplace and lighting issues or the importance of lighting, it's generally talking about that horizontal illuminance for the most part. Most of the work that we do, whether it's in on an assembly line or in a hospital operating on someone, it's that horizontal illuminance that is most important. So we think about that work surface or a shelf or a floor, right? But vertical illuminance is also important. We think about lighting up things like walls or a vertical aspect of a part or something like that. So both are important, but really when it comes to illuminance, it's that horizontal that we focus most on. When it comes to glare, we generally differentiate between direct and indirect glare, but both really refer to that excessive brightness. Excessive brightness that really results in visual discomfort, either immediately from a very bright source or over time we sort of are impacted by that, right? So a direct glare is that bright light source itself that in the field of view. And we can see that in the top left image there with that light fixture pointing directly at the field of view for that individual. That would be the direct glare source. So generally a light bulb, a fixture, or the sun itself. An indirect glare really refers to any kind of reflection on a surface. So it could be a glossy finish, shiny metal, stainless steel, windows, glass, these types of surfaces where that reflection is high, and we end up with that indirect glare, and you can see the top right, that direct glare from the light fixture pointing on the monitor directed into the eyes of the individual. And the bottom picture there, a guard made of a glass covering or something like that, that the light source is causing indirect glare into the field of view for that operator. Contrast, important to understand, and really referring to the difference in luminance or color that makes an object distinguishable. So, contrast is good in that sense because we need to be able to distinguish textures, distinguish one object from another, or in the example of the picture on the top there, we need to distinguish one step from another, a rise from a run, for example, right? So we have to, if we have good contrast, then we're able to distinguish that, detect differences in elevation and textures and things like that. And it's essential for good visibility, for safety, for object definition. And that's why we have those often changes in elevation are depicted or addressed, I should say, with a kind of bright yellow strip, as you've likely seen. But it can be bad too, right? So if we have contrast that is low or too low, it makes it difficult to differentiate. So an example, that picture on the top left may be difficult, especially if the light was lower, a poorer condition, then that contrast being low may be difficult to distinguish one step from another or a rise from a run. And it can also be not great if it is a high contrast. If the contrast is too high in the sense of that picture on the bottom there, where we have very bright light sources with a dark ceiling, and the visual fatigue associated with continually adapting between sort of the bright and the dark in the visual field can lead to that visual fatigue. Shadows, we all kind of understand what shadows are, obstruction of light in some way, whether it's the body that is blocking light from behind and casting a shadow on the workpiece or on a person that you're treating. It could be anything like that, as well as any structure. So maybe a rack or a shelving unit that is blocking a light fixture, which casts shadow in an area. And it can be an issue if it creates those dark spots or poor visibility and dark areas where hazards could be lurking, right? But it also is important when we think about kind of the good side of shadows, in that it helps us, again, as far as definition, as far as detail, right? We need those things when it comes to things like quality or working on a patient. We need that definition and understanding the differences in elevations and that sort of thing. Our depth perception is very important, and when we don't have any shadows at all, that can be difficult. So we do need some shadow. We need a balance between that vertical and horizontal illuminance. That ratio needs to be optimized, and that'll be different for the task that you're doing. Light distribution and uniformity is very important as well, and really refers to how light is spread or cast across a space or an area. And so when we have those extreme differences between very bright areas and dark areas, it's not a very uniform environment, and we are continually kind of adapting in our visual system, and again can lead to that visual strain, fatigue, and maybe even have some of those dark spots where hazards can be hard to detect. And just the example to the right of kind of poor versus better light uniformity, and you can visually see that. Flicker, important to understand as well. Won't go into a great detail with this because it is quite complex, but we think about flicker as a rapid variation or change in light source intensity. And we can differentiate between what we call visual flicker, so you can see that flicker, and fluorescent lights used to be a culprit for this, where you would see that almost strobing effect, and some people would be more sensitive to that than others. They changed to newer ballasts and kind of got rid of that issue for the most part with fluorescence, but we are seeing it more with LEDs now, especially with LEDs with that dimming capability. And we're also, we know more about sort of what we call non-visual flicker or temporal light modulation as well, where we're not visually seeing that stroboscopic effect or that flickering itself, but our brain is still detecting it in a sense. And so those non-visual flicker frequencies can affect our bodies when it comes to fatigue, so eye strain, headaches, all these sorts of effects. And Steve will talk about that a bit more in a little bit. But good to understand sort of the difference when we talk about pulse width versus amplitude from LEDs. So pulse really controls the output of a light through kind of turning on and off. And so I put that picture on the top right there where we think about a light being turned on and then turned off, and kind of doing that on a frequency. If it's done at a frequency we can see, then it's a longer off section, I suppose you could say. But if it's non-visual, we may still pick that up and it may still affect us, right? Like I said before, with headaches and fatigue and that sort of thing. Amplitude, if it's modulated through amplitude compared to pulse, it is better because it's more of a continuous brightness without flicker. But the downside of that is it is less energy efficient, which is why some may kind of go for that pulse modulation because it is more energy efficient. So good things to consider. And just an example of here, a variety of different light sources that may be in a work setting, a workplace, and this being an office for this one, where we have our overhead lights, right, which may be that kind of direct light from above, and we have the direct light maybe from a window, hopefully from the side, not directly in front of you or directly behind. Perpendicular to your line of sight is the ideal position for a window, so you can reduce glare. But you may have that light from the window. You may have an indirect light on a wall that you see on the left side there, where indirect lighting means not directly lighting your workspace, but pointing up and down, casting the light indirectly in that manner. And you may have a task light, as you see on the desk here as well, to brighten up a source, a writing surface or notepad or something like that, because writing requires a higher illuminance than sort of other tasks like the computer would require. Of course, we have the monitor light there as well that may shine as well. And so many different sources of light that would be in this situation.
Thanks, Nathan. We'll switch our focus, pardon the pun, to the eye now and talk a bit about vision and how it is we are able to see and focus on the objects that we see in our environment. Essentially, light from an object, the luminance, as Nathan spoke of, entering the eye, passes through that pupil aperture, and then through the lens and through the inside of the eyeball to the back of the eye, where there are light-sensitive receptors called cones and rods. The cones give us our color vision. They are sensitive to brightness and require high light levels, which allow us to bring objects into sharp focus or acuity. There is a high concentration of cones at the fovea. So when we are trying to bring something into sharp focus, we will instinctively turn our eye until the image falls onto that spot on the retina. Now, outside of that really foveal sharp focus zone, the rods are more abundant, so there's not as many cones. And rods are more sensitive to dim light and are relied upon for our vision in low light conditions. And interestingly enough, they can only provide images to our brain in black, white, and shades of gray. And they do not produce sharp images. However, they are very sensitive to motion. So they are quite integral in our peripheral vision. So I wanted to kind of just try a little exercise to help demonstrate these concepts of the centrally sharp focus zone of our visual field and the work of our rods. So at home, try this exercise. If you have a pen or a small object that you can hold out kind of about an arm's length in front of you. And I want you to focus on the tip of the pen or a really small part of whatever that object is you have in your hand. And I want you to hold your focus on that item and continually hold that focus. And while maintaining your focus on that object or pen, move your other arm into your periphery, starting close to the pen and then moving away to the outskirts of your periphery. But do not stop focusing on that pen. What you'll notice is the image of your hand that is outside of that central vision where you are focused on that pen is blurred. You know your hand is there, but it's not a crisp image. And when you move your hand even further into the periphery, it will keep, if you keep it still and it's way in your periphery, you won't even really detect it. But if you move a finger on that hand, you'll note that movement. So what we do is we rely on our rods for detection, and then our brain will process if we need to divert our attention and focus on a new target in our central vision. But we can only at any given time really keep a narrow focus on that very, very narrow central zone. Another example that highlights the performance of the rods, think about going for a walk outside in a dark environment. Maybe you're at night on a trail and there's no street lights, and you're walking along and you detect movement in your periphery. And your attention is diverted, it's doing its job. You turn to try to focus on what you saw move, but you're not able to see it. You're not able to capture a sharp image of it. And this is because our cones need more light than our rods, and cannot bring that item into focus, but the rods could detect the movement in the first place. So it kind of gives you a bit of a sense of the balance of, how that eye, those elements in our eye sort of work together, and what the some of the shortcomings are related to the amount of light available in the performance of the task. This slide shows an image of the visual field, and it depicts that there's three zones. Zone A is that central foveal zone of sharp focus that I was just talking of, that where you can bring everything into a very sharp image. Now, zone B was that middle field where our hand was sitting and it was partly out away from that pen that we were showing. And in that zone, the image isn't sharp, but objects that have strong contrast and that are moving can be noticed and divert our attention. So it's kind of that zone that helps us sort of be constantly, because we don't keep our eyes focused on one single thing all the time. We're always changing that central foveal vision. So these two work together. Now that third zone, which is much further out, is the outer field that extends out to the boundary created by our forehead, our nose, and our cheeks. And objects in this region really are not, if they're not moving, they're not going to be perceived. So essentially, when we consider our peripheral, the concepts of movement, of the size of the object that we are that's in that periphery, and the contrasts with the environment are critical for detection. So these concepts are important to remember, particularly as they relate to workers navigating through their work environments, either on foot or operating mobile equipment, and that the lighting conditions in that environment can influence how well objects in our periphery are detected. So lighting can help to optimize contrast, and we will talk on that by creating uniform lighting, and Nathan was mentioning that, uniform lighting conditions, but can also hinder as well. For example, when our eye is exposed to glare, the sensitivity of the rods, as we talked about, are affected, which influence our visual acuity and the contrast sensitivity, or our ability to detect something in its background. And that can negatively impact, as I mentioned in the example, when I opened the session today, was a prime example of that, where that the bright light source from the light behind the mirror affected the operator's the visual acuity to be able to detect those images on that mirror. So we can see how that interaction between our different lighting, our different visual functions impact our ability to see and detect in our environments. Lastly, I'm just going to touch on some of the key visual functions that are useful to understand and give you perspective on the impact of lighting on health and safety. So it kind of will set you up for sort of understanding that the health and safety elements related to lighting. So first off, accommodation, which is the ability of the eye to bring into sharp focus objects at varying distances. So again, there are small muscles that control the pupil aperture to allow how much light's coming in, and the curvature of the lens, which helps divert the light to that foveal area on the back of our eye, which are important for bringing objects into focus. So they are allowing the necessary amount of light and the lens curvature to provide a crisp image to the fovea on the retina. So to demonstrate this visual function, again, if you hold your pen out in front of you and you focus on your pen, and then you switch your focus to beyond the pen, you'll notice that the pen is no longer in focus, but what's behind is now in that sharp focus. So when we're focusing on objects closer to us, there's more curvature of that lens. Is needed to kind of focus that light in. And when gazing at distances or to the horizon, the lens flattens out. So we put this in context in terms of a work task. Highly demanding close-up work can fatigue the muscles that bend the lens. And by shifting our gaze to the horizon, we can let those muscles rest momentarily. When we are performing a task like we all do, computer work or writing that needs a certain amount of light delivered to the retina, and we're exposed to a bright glare source, again, the muscles of the eye that are trying to optimize the amount of light and the image focus can become fatigued, just as Nathan had touched on that. So the next concept is visual acuity. Now, this is our ability to detect small details and discriminate small objects. Our visual acuity increases with the level of illumination, but there can also be some limitations. So too much light can negatively affect visual acuity as well. When you're exposed to a very bright light source, as when we are driving at night and we have those bright, intense lights that come into our eyes, that can impact our ability to bring into focus objects because of that intense disability glare. The next item is adaptation. We have all experienced this visual process when we've come inside to a dark room from a sunny day. It takes a few minutes for our eyes to adjust to the new level of illumination. And we can also experience what's called a partial adaptation. For example, when there's a bright light that's off in our visual field, but not directly in our visual field, the glare impacts the sensitivity of the retina, which impacts our visual acuity. Contrast sensitivity. This visual function is quite important for navigating through spaces and performing visual inspection type work. I think Nathan touched on that when he was talking about the contrast on the stairs. So bright light exposure to the eye can negatively impact contrast sensitivity. For example, bright light shining into the eyes of a person navigating a walkway at night, the glare can interfere with the detection of ground hazards that may have a very low luminance contrast. Also remembering that we do need strong contrast in our peripheral vision, which further impacts the detection of the edge of the walkway. So we can see how lighting can have a significant influence on our contrast sensitivity. Lastly, the speed of perception. This is essentially the time between visually detecting and the perception of that visual signal in the brain that there's something has been observed. The speed of perception improves with lighting and with greater luminance contrast. So things are, there's greater contrast and higher light, amount of light, then your speed of perception is going to be elevated. And this is kind of critical where hazards need to be detected and perceived so that adequate lighting and contrast are essential. So I'm going to pass it back to Steve, who will pull the concepts that Nathan and I have touched on into the workplace health and safety realm. Steve?
Thanks, Lisa. So we're going to go into Module 2, Lighting and Workplace Health and Safety. How does lighting, can it prevent accidents and injuries? Well, it can. Adequate lighting in work areas, hallways, staircases, and emergency exits help employees see the hazards that are present. Poor lighting can lead to trips, slips, and falls, especially in warehouses, construction sites, or areas with machinery. In summary, poor lighting equals more mistakes, stress, and injuries. Good lighting equals safer, healthier, and more productive work environments. So lighting and health effects. So disruption of circadian rhythms is too much artificial light, especially blue light from the screens or bright overhead lights at night. It can confuse our internal body clock, known as the circadian rhythm. The disruption can make it harder to fall asleep or wake up feeling refreshed. As far as eye strain goes, eye strain and discomfort from poor lighting conditions can be whether the light is too dim or too bright and can cause eye strain. So this happens when your eyes work too hard to focus, often leading to discomfort, blurry vision, or even dry eyes after long periods. For headaches and migraines, certain lighting like flickering, Nathan mentioned earlier, flickering lighting, fluorescence, harsh glares can trigger headaches or migraines in sensitive individuals. Consistent exposure to this kind of light can make work and daily tasks much more difficult. Mood lighting. Lighting can affect our emotions. Bright natural light can boost mood and energy levels, while dim or overly artificial lighting might contribute to feelings of sadness or fatigue. In fact, light therapy is even used to treat conditions like seasonal affective disorder. And improve sleep quality. The right kind of lighting at the right time can improve your sleep. Warmer, softer lights in the evening signal to your brain that it's time to wind down. Limiting exposure to blue light before bed helps support a deeper, more restful sleep. Thank you.
Thanks, Steve. So we'll transition now into the workplace settings, and we'll discuss various types of hazards and how lighting may contribute. So we can obviously see in this picture here to the right, a poor workplace condition on a stairway, and some significant concerns there if we think about what that low lighting level and the shadows, the poor contrast, as we mentioned, not being able to detect changes in elevation, spot hazards like debris and things on the floor can be a significant issue. So slip, trips, and falls. Many may be able to be prevented if we think about improving the lighting conditions in those areas, such as a dimly lit stairway, walkways, anywhere that there might be objects in the path of travel, or even places like dark parking lots. So slips, trips, and falls is a big one that lighting can help prevent. Struck by is another one, and we think about, as the image shows, a reach truck or a fork truck, and operating those in poor lighting conditions, whether it is dark shadows, poor uniformity, or just an overall dark space. Significant concerns there if we think about pedestrian and forklift interaction in those spaces, where a fork truck driver who already has a limited line of sight because of the mast, because of the different components of the forklift that blocks their line of view, and we add a poor lighting condition, and we got a recipe for struck by incident where a pedestrian gets struck because of the poor lighting and poor visibility. The opposite can be true too, where if we think about similar to Lisa's example off the top there, where operating a fork truck to the top or to the high levels, where the view of the actual light fixtures might be in their direct line of sight when you're trying to see or view items at the top or access items at very top levels of racks, and we get the glare associated with that while we're handling these heavy items that could fall and tip and eventually strike someone, right? So we may have those kind of blind spots after looking directly into a fixture as well, or into bright sunlight as well, if we're going from an indoor space to an outdoor space, and the impact of that, as Lisa was saying, how our contrast is affected in those scenarios and leading to those types of incidents. Adaptation, again, going from bright to dark. It could be on a forklift, or it could just be walking in and out from internal to outside, an indoor environment to an outside environment, quickly changing, and the adaptation and accommodation that's required in those scenarios. It could be items that are stacked too high, or a rack that's actually blocking light fixture, obstructing view, causing shadows, and the associated hazards that could come from that. We think of cuts and scrapes and those types of hazards. So anywhere that there is kind of a poor light condition or poorly lit objects, we may think of sharp corners of a work surface, or sharp tooling, hard objects that you may run into and scrape yourself on. Corners of work surfaces or equipment, and just being able to detect and identify those cut hazards is limited in those lower light environments. We could think about equipment and machinery, and again, that detection, where we think about something like a crane sling or a fall arrest system, these safety devices that we rely on to keep us safe. If we're using them or operating them in a poor light condition, we're not going to be able to see if they're worn, or they need replaced, or they need to be taken out of the system. A grinding wheel, for example, as well, that may need to be switched out, and it's, we're not going to be able to detect that there's a problem or that it's worn, and it could kind of separate and fly and hit someone in the eye or something like that, or in the face. The ability to detect those moving objects, moving parts, conveyors, rollers, whatever the equipment, machinery that we're working with is, difficult to detect sometimes those moving objects if we're in lower lighting situations, or shadows or cast. Even something like the warning signs or information signs. So thinking about the when you enter an area where hearing protection is required, for example, or safety glasses, and if those signs are not well lit, right, you're relying on those awareness signs, awareness controls to alert people. And if they are not well lit, or they're covered in dust, or they're dirty and not visible, you're going to have issues, and people are not going to be made aware of those situations that they're walking into potentially. May have dust buildup or degradation of the fixture covers, so the lights themselves, they can get dirty, which can affect the lighting situation, reduce the lighting in the environment. And then of course, any shiny, glossy surfaces. A lot of times with machinery, we have this, metal surfaces, materials that may cause glare. Of course, we'd be remiss as an ergonomist to not discuss musculoskeletal disorders. And so awkward postures is a big one when it comes to lighting. And you may notice this where you change your posture to see, for example, in an office environment, to see what's on the screen. You got small font, or the lighting is poor on a page and you need to see it better. You're going to adjust your posture, lean forward, get in an awkward posture potentially to be able to improve your view of what you need to see. On the opposite side of it, you may change your posture and position to avoid a certain glare. I remember I did an assessment one time with a receptionist, and it was a certain point of the day where the sun was going down, and it was pointing directly at her face and getting that direct glare from the sun. And so she would stand there in an awkward sort of side bend, rotated position just to avoid the glare, but she had to be in that location. And instead of, addressing some of the issues, she just got used to that sort of awkward posture to avoid that direct glare in her face. And so we see this often with people adjusting their posture and position in order to kind of improve the view or to avoid a certain scenario. We see tension and fatigue from headaches. We've talked a bit about those health effects that can come on. Steve mentioned that, but poor lighting can result in that, and we get the awkward sort of slumping and slouching from that fatiguing. Visually, we get tired. We get that associated muscular effect there as well, and we get tension in our neck and our head, and from that frequent sort of visual adaptation. Squinting as well, right? We try to see something better on a screen or on a page or on a label, and we squint. We kind of try to get a better view to change the shape of our eye, as Lisa was saying, so that we can see it a little bit better, and the effects of that on the muscles of the face, but also turning into a headache eventually as well. And one that may not seem quite as intuitive is the increased physical demands from a poor lighting situation. So if we think about an order picker or someone working in a storage area where they have to do a lot of handling of items or identifying items, picking of items from a location, and an order picker may double or triple handle items, and even more if we're in a poor lighting condition where it's difficult to see the items that they need to access. And so we might end up, doing a lot more handling of items and more physical strain on the body because of that. Mental health and well-being also important to discuss as well, and Steve touched on this as far as the morale, as far as the mood goes. And we know that the low lighting levels or lack of natural light does affect our mood. We often get into those poor mood situations in those low lighting levels or lack of natural light situations. And in turn, we can have some psychosocial dynamics as well. If we think about the difference in, maybe what Lisa's preference for lighting is compared to mine and then Steve's, and we all have a different preference for one, but also we have different sensitivities. There's 20 to 40% of the population that is more light sensitive. And so a really bright environment like you maybe see in the picture here, some people may have a difficult time with that. And we also have maybe 5 to 20% of the population that have extreme light sensitivity. And so we really have to kind of think about accommodating all individuals and making it work for most people, which is what we're all about with ergonomics. And so can be difficult when we think about lighting preferences, lighting sensitivities, and finding that balance between, not a dark environment and not an environment that's too bright. So avoiding the glare, avoiding the excessive brightness, and adequate lighting, very, very important, but can be challenging in these types of environments. As well, important to understand from a mental health and well-being standpoint, we all want to be safe. And whenever we think about lighting in a place like a parking lot, dark corners, dark stairwells, these places often associated with kind of darker situations from a lighting standpoint, people don't often feel safe in those environments, and so we have to address that. And so good lighting in those areas, a brighter lighting than maybe what we're used to, helps reduce that risk of violence and harassment as well. And not necessarily directly connected to safety, but productivity and quality, very important, obviously, to probably everyone who may be viewing this webinar. From a productivity standpoint, right, we think about lighting directly impacting performance. We have happy, more comfortable workers who can see what they're doing well, and they're not straining themselves or their eyes. They're going to be more productive. We optimize that lighting level. It's going to increase their alertness and their cognitive performance as well. From a quality standpoint, we think of the quantity and the quality of the light itself and how that directly impacts being able to detect a defect in a product or a procedure or an issue or a document, whatever it might be. That quality can be affected if our lighting levels are poor. And so lighting that adequately reveals, as I mentioned before, differences in depth, shape, texture even, is very, very important, especially in those quality type roles. So key point here is that lighting really needs to be appropriate for the task. And there are different guidelines, different recommended practices for different lighting levels for various tasks out there, which Lisa will discuss in a little bit. Over to you, Lisa.
Thanks, Nathan. So I'm just going to touch a little bit on now you're probably wondering, so what's required of employers regarding lighting under the health and safety legislation in Ontario? We have to first start by looking at the Occupational Health and Safety Act. So all provincially regulated employers must comply with the Act, and this is Ontario's legislation for health and safety. So the main purpose of the Occupational Health and Safety Act is to provide basically a legal framework to achieve our goal, all of our goals of protecting workers from health and safety hazards on the job. And in doing so, it sets out duties for all workplace parties and ensures rights for workers to establish a strong internal responsibility system in the workplace. So we're going to talk a little bit further on that in terms of having a process in place to address lighting concerns. So the strong IRS sets the stage for workplaces to support a safe and healthy workplace where everyone has a role to play and keep workplaces safe and healthy as you'll see later on in the presentation. The Act also establishes an opportunity for measures and procedures for dealing with specific workplace hazards. And this is where we see those specific measures might be listed out in specific regulations. So I'm going to touch a little bit on that, the specific regulations where lighting is discussed. But there's also some general requirements that are found in Part 3, which is under the duties of the employers and other persons section of the Act. And there are some duties that are established out for employers, specifically a couple that come to mind that might relate to lighting is the duty to maintain fixtures in good condition. So it's not specifically fixtures, but this section relates more generally to the maintenance to maintain items in play at the workplace in good condition. And then there's the section 25(2)H of the Act, which essentially it requires the employer to take every precaution reasonable in the circumstances for the protection of a worker. So it's a very, very general clause, but it is very broad where there's a hazard that isn't explicitly identified in a regulation. There is a requirement for the employer to take precautions, reasonable precautions. Now, when we look at the Act, there are actually 27 different regulations under the Occupational Health and Safety Act. There's only 4 that I've shown here on the slide, and these are sector-specific regulations that are under the Act. There are other work-specific types of regulations, such as like the confined space regulation, or there might be hazard-specific regulations like the control of noise, the regulation for noise. But I'm going to focus in on these sector-specific regulations because this is where we find the provisions related to lighting. So there is no standalone regulation that deals with lighting. So we look within each of these different regulations for specific sections that will address lighting in those specific areas. So Regulation 851 deals with industrial establishments. Regulation 67 is for healthcare and residential facilities. 213 is for construction projects. Included this one because there may be situations where you might work at a workplace that is an industrial workplace or healthcare, but you have a project that's being undertaken, a construction project there. So knowing sort of the lighting requirements under that section would be, informative for you. And there are lighting provisions in the Regulation 854 for mines and mining plants. However, I'm not going to be going through those today. So starting with the industrial establishments, the section this requirement is has quite a bit packed into it. So first, when where natural lighting is inadequate to ensure the safety of a worker. So safety is a key element here. And this can relate to safety of navigating through a space, or it can relate to safety of performing a work task. It's very broad. It then requires that artificial lighting be provided, and then speaks to the quality of the light provided, and that shadows and glare be reduced to a minimum. So what it does not provide is a specific lighting level that is needed. And the reason for this is it recognizes that lighting needs can be quite variable depending on the task being performed, as Nathan was alluding to there. So it is a very general sort of performance-based type of section. Now, switching over to the healthcare and residential facilities regulation, they have several sections that relate to lighting in the workplace. Section 22 opens with the requirement that the illumination provided meets the minimum lighting requirements set out in Part 3 of the Building Code. However, it moves beyond that, again, speaking to the lighting quality, discusses brightness levels and ratios, so that, and also getting into the uniformity of the lighting in the space. The section also notes glare contrast, and shadows maintained at a level that is not likely to be a hazard to the worker. Again, that hazard could relate to simple navigation in a space, or it could also be the safe performance of a task. Maybe you're using a certain type of equipment that has some hazards associated with its use in a very refined way, that you need appropriate lighting so that the task is done safely without injury to the worker. The subsection 3 clarifies that if there is glare, that it is reduced as far as practicable. So an example might be a workstation near a large exterior window with glare affecting the worker's ability to see the computer screen. Now, the glare control could include a number of measures, such as blinds or shades, screens, coatings on the window, but it could also include relocating or reorienting the workstation. So there's different sort of approaches that can be taken in terms of the practicable measures to address the glare and reflection. The regulation also has a few other sections relating to lighting. Remember in my earlier discussion regarding the visual acuity and how the lens of the eye must bend to allow us to focus on close-up things. So when we're working on a computer screen for long periods of time, the muscles of the eye can become fatigued. And this section 24 regarding the continuous use of a video terminal supports this need to give the eyes a rest and look at something in the distance to allow the lens to flatten and the muscles to relax. It's that, obviously there'd be also that benefit to the musculoskeletal system as well, whether it's an awkward posture, from other musculature in the body, but it really does speak to that eye musculature as well. Lastly, again, sticking with the healthcare regulations, there are additional sections in the healthcare regulation you can see in 26 and 27 here that relate to the maintenance of light fixtures. So again, other regulations don't have something specific to maintenance, so they would use the general maintain in good condition under the Act. But in healthcare, there are some specific requirements related to lighting and maintenance that are explicitly identified. And as I mentioned, I included these sections for construction projects, as there might be circumstances at your workplace where you have an active project on the site. These sections speak to adequate lighting. So the terminology used here, again, adequate for a passageway would need to ensure hazards along the passageway can be detected to avoid slips or trips or contact with obstructions. And the second section that relates to lighting in the construction projects relates to access egress routes to the work areas, as well as the lighting in the work areas themselves to ensure, again, hazard detection and the safe performance of the work tasks are maintained. Now, as I mentioned, none of these are explicitly saying the exact amount of illuminance that needs to be in a particular area. And this is where, there is other guidance that can be helpful in terms of identifying appropriate or suitable levels of light for particular tasks. And there are these guidance documents that employers can examine to help sort of determine that appropriate lighting provided in an area. So the American National Standards Institute, ANSI, and the Illuminating Engineering Society, IES, produce many recommended practice documents, so RPs they're called, that can be helpful in understanding the lighting goals for a given environment and the tasks being undertaken in those spaces. There are a few listed here, so you can see recommended practice for industrial facilities, for hospital and healthcare facilities, for common applications, and these would be, lighting areas that happen everywhere. So it could be storage areas or shipping and receiving or lunchrooms, and those are those sort of common spaces. There's also an RP for lighting of office spaces. There's others that might be of interest to you: lighting for exteriors of a workspace, lighting for safety and security, as well as lighting for parking lots. So there's lots of potential resources out there to sort of investigate lighting levels that would be suitable given tasks that are being performed in a particular area. And again, there is information in the building code part 3 as well related to lighting. And it's helpful to know at least that these references exist, particularly if you're working with a lighting contractor or an engineer who's working on a lighting system for you. You can ask about the lighting installation you may be undertaking and how it will compare to a recommended practice. It's good information to kind of be aware of. Now, within these, most of the recommended practices publications will provide information about illuminance targets. So you can see in this is just a little excerpt from one of the charts that's found in the Common Applications RP. And it's a chart that kind of looks at what are the maintained illuminance targets for different areas in common applications. And I just highlighted a storage area as an example here. And lighting needs will vary depending on the task. So these tables provide quite a bit of information, including the lighting level for the task or the area. So this A that's here is basically saying these lighting measurements that are listed in this chart are for the whole area. They're not for a specific task in a very task-specific lighting provision. It's for the broad area. And both horizontal and illuminance and vertical illuminance values are provided. So this is the illuminance that is falling on the horizontal surface, and often that will either be identified as a floor surface, or if this has a T here where it's a task, that will be a horizontal surface of where that task is occurring. And they also provide vertical illuminance recommendations as well. Again, particularly when you think of storage and you have to read labels that are on the vertical surface, that vertical illuminance is what is going to provide you with the necessary lighting to be able to read those labels. And you can see here the storage has identified small, medium, and large items, and you can see how the illuminance levels vary because small items, obviously, when we talked about our visual acuity and being able to focus on small things, we need more light for that. So you can see the horizontal illuminance targets are higher where you're dealing with storage of items that are small versus storage of larger, bulky items, sort of thing. So again, this guidance can be very helpful in identifying sort of what an appropriate light level for the area would be. You can see here that it also talks about uniformity. Nathan mentioned earlier in the presentation that spaces that have dark areas can make it very challenging for the eye to be able to focus and be able to see things clearly if there's a darker area within that or a brighter area and that too much uniformity is off there. So there is a uniformity ratio that is given here that basically you can look at your average illuminance and compare it to your minimum illuminance in that area to see what the ratio is, to see that you don't have those sort of excessively dark spots that are landing in your workspace and causing issues related to that. So when planning or evaluating your lighting, it's really important to consider the work being performed, the critical tasks that occur, and the hazards of the work. So, for example, general conveyance and access egress, the lighting must allow for hazard detection, protrusion to prevent slips and trips. But in comparison, a workstation with an inspection task, that requires a worker to detect really small imperfections will have a very different lighting needs. So this sort of, there's lots of resources out there that can help you sort of discern what your needs are. So this is kind of a perfect segue to our next section of the webinar. I'm going to pass it back to Steve to discuss approaches to planning and evaluating lighting in the workplace. Over to you, Steve.
Thank you, Lisa. Okay, so I'm going to introduce two models that can help with identifying and improving lighting conditions. The first is called Plan, Do, Check, Act, or PDCA. And the second is Recognize, Assess, Control, and Evaluate, or also known as RACE, or ACE. We will talk in more depth about RACE as it is best suited to address an immediate hazard. So as you can see in the chart here, over on the left, you start out with plan. So you want to figure out what it is that you want to change. So you're doing a study or you're reviewing the current condition. You want to engage workers in the health and safety committee, and you want to ask them questions. Involve purchasing and maintenance also. They have a lot of knowledge about the lighting, and select a knowledgeable contractor. Then you come to do. So understand your current condition, understand the task performance needs, and consider a pilot or a trial if you're going to change lights. So for example, if it's in an arena, you might want to just do 10% because they might not be adequate, and you don't want to do 100 lights and then realize they're not adequate. Then it goes down to the ACT section down the bottom left. So make adjustments to address lighting concerns, re-engage workers, and then check is engage with workers, health and safety, check your levels. You can measure the levels, identify glare and shadow related issues. So this is more of a continuous improvement model. And the RACE model is really one that is better for the specific hazards. But I thought I'd introduce this one also. So RACE is recognize, assess, control, and evaluate. So this model it's a risk management practical framework used in occupational health and safety to identify and manage workplace hazards. So including those in lighting safety. So here's how it works. You start off with recognize. You go around, as you can see by the direction of the arrows, you go around to assess, and then you go to control, and then you go to evaluate. And I'm just going to walk through what that looks like a little bit. So identifying lighting issues and hazards in the workplace, you have to think about certain things. Are areas too dim or too bright? Are there flickering lights that could cause discomfort or migraines? Are emergency exits properly lit? Are there areas where glare or shadows that could lead to accidents? So in examples, you notice that the warehouse aisles are dimly lit and workers struggle to read labels on the boxes. So you want to look at reports. You want to talk to people. You want to see what they have to say if they have an opinion on lighting. Look at incident reports and look at lighting risk identification checklists if you have it. And the types of things you're looking for are low levels of light, shadows, glare, contrast, excessively bright. Workers having symptoms like headaches, migraines, eye strain, fatigue, and injury root cause. So the next part is assess. So you want to ask yourself these questions. How likely is it that poor lighting could cause an injury or health issue? What tasks are affected? So is it operating machinery or reading screens or reading labels, those types of things? And are any workers more vulnerable? So for example, nighttime or shift workers, that's those types of things. So an example is you could assess that poor lighting increases the risk of forklift collisions and employee strain. When you go over to the slide, they talk about doing a light assessment. So there's equipment available called a light meter. That's usually performed by an ergonomist. You can compare it to the IAS standards that Lisa spoke about, and then identify root cause of poor lighting, glare, flicker, shadows, reflective surfaces, and then you want to look at it objectively, subjectively, and you want to look at your injury and incident data And then you want to do something called the 5Y, which is associated with the fishbone. So here's an example of how to assess workplace lighting issues using something called the 5Y. You would ask, well, it's essentially that. It's 5 Ys. Why is there poor lighting in the office? The answer, because several ceiling lights are not working. And you ask why again. Why are the lights not working? Because the bulbs have burnt out. Why were the bulbs not replaced? Because no one noticed or reported it. Why did no one report it? Because there is no regular inspection or reporting process. And the 5th why is there no inspection process? Because there is no assigned responsibility or policy for lighting maintenance. So when you ask 5 times, it's the same concept as accident investigation. You get down to the root cause. It's not just the first why. There's poor lighting in the office, and it ends at that. And once you drill down, you get down to the real reasons why there's a problem. So for control, so what would you do? You would look to reduce hazards. You would look to reduce accidents, enhance visibility, boost productivity, and reduce comfort complaints and discomfort. And you may have heard these terms before. When you control hazards, you control them at the source, along the path, and at the worker. And of these, at the source is the best way to do it. If you can get right to the lights and you can make adjustments, either maybe different bulbs, maybe they need to be shifted to a different angle, that's the best way to do it. Sometimes your only option is to do it at the worker, but that's not the ideal way. So let me just give an example here of control at the source. So here's some examples. So you could replace harsh or flickering lights with high quality flicker-free LEDs. Use diffusers or frosted covers to soften them. Install dimmable lights or lights with adjustable color temperature. Design lighting systems to provide uniform, adequate illumination, and avoid direct line of sight to bare bulbs by using shielding or reflectors. You need to prevent lighting problems before they affect people or spaces. Control along the path. So this is the second best way to do it. These measures reduce lighting issues as light travels through the environment. So examples include install window blinds, shades, or tinting to control natural light and glare. Use matte finishes on walls, floors, and desks to minimize reflections. Reposition reflective surfaces or light sources to prevent indirect glare. Organize workstations perpendicular to windows to reduce screen glare. And install baffles or louvers or directional lighting to limit light spill and glare. So the goal is to manage how light interacts with surfaces and spaces before reaching the worker. The control at the worker, the different things you could do is provide task lighting for detailed work, use anti-glare screen filters for computer monitors. You could offer tinted or anti-glare eyewear, train workers to adjust light sources and recognize poor lighting, and encourage regular eye breaks to reduce strain from screens. Also with control, so for lighting, you want to look at lighting quality, lighting quantity, optimize reflection, reduce, eliminate glare, and uniformity. So you need to consider the environment, the task, the cost, the maintenance, and the hierarchy of controls. And if you're doing it in, for example, a hospital, everywhere is not going to need the same light. You're going to need certain light in the emergency department. You're going to need different light in an operating room. So even in one workplace, you're going to have different levels of light that are possibly required at different areas. Other areas for control. Other areas for control are improve or upgrade your fixtures. Add task lighting where you can. Use diffusers or anti-glare screens again, and then ensure emergency lighting is functional and tested regularly. Lastly, for control, so you want to, we've already talked about diffusers and filters, lenses, louvers, and dimmers, but there are different ones you can purchase. Some, for example, is like a tint on your car window. You can have a light tint or you can have a dark tint. And then and you can adjust that accordingly to the light that you want. So luminaire quantity and quality is important. So you need to consider a number of luminaires and the type that's coming in. So direct versus indirect lighting, pendant, track, recessed, spot, or high bay lighting, overhead versus task, and LED. incandescent, fluorescent, etc. This is the last one on control. So reflection, we want to talk about reflection on ceilings, walls, surfaces, desk, and the work table. There's a diagram on the right. It references surfaces. So it just shows different percentages of where you would get a higher level of reflection. And the goal is to make it consistent. Continuity is important with your lighting in the workplace, so you don't want one source shooting in light, making it too bright in one area. So reflection has a significant effect on lighting in any environment. It can enhance visibility, create glare, distort perception, or even reduce lighting efficiency, depending on how surfaces interact with the light. The light reflects off light-colored or glossy surfaces like walls, polished floors, or glass. This spreads light more evenly in a space and can reduce the need for extra light sources, and the positive effect of it improves ambient lighting and energy efficiency. So for evaluating for the E in the RACE acronym, you want to monitor and review the effectiveness over the controls over time. Are workers more comfortable and productive? Has the risk of accidents or complaints reduced? Are lighting systems being maintained properly? And after changes are made, you collect worker feedback and track incident reports. If problems persist, further adjustments are needed. So you need to reassess, keep an eye on it, talk to the workers, look at the information that's coming in, consider your preventative maintenance schedule, consider inspections, and consider doing a worker survey. And after that, I would like to thank you, and I'll pass it back to Nathan.
Thanks, Steve. So just to round us out with an example of walking through this race process using a poor lighting condition in your case study. So an industrial printing facility, if we look at these two images here, and we try to start with that R, the recognize component, we try to find some of these poor lighting conditions or hazards associated with it. The first here being the light sources themselves. So switched out to very bright LED pots instead of kind of not quite as bright fluorescent banks, and very, very quickly workers reported issues, concerns, headaches, concerns as far as not being able to do their work properly, quality issues, these sorts of things. So you can imagine how important quality is in a printing facility. But first off there, those bright pot lights really affecting people. And you can see in the left picture there's a workstation with a blurred out worker there and a monitor. Hopefully you can see it there. A monitor there showing where a worker would be observing, looking at that monitor regularly. And if you follow that line of sight from the worker's head, and I'll grab a laser pointer here to better see here. So far from the head to the monitor, and we follow that out straight out, we have these light banks that are right in their field of view while they're looking at that monitor. And so eye strain associated with that constant bright source, direct glare right at them whenever they're looking at that monitor, and concerns related to that. And if we look at the shadows that you see, kind of various different shadows, difficult to maybe see in this picture, but what would happen is an array of shadows was basically cast on the work surfaces and the work materials. So again, a printing environment, quality is pretty important, got to make sure we're not outputting defects. And so an array of shadows on printed materials could be very significant as far as not being able to detect those things. And as well, workers required to use different gauges and stainless steel ruler, for example, to measure something, and the array of shadow cast onto that ruler, making it very difficult to actually see the measurement that they're able or that they need for that task. And so very difficult for these workers to do their work. And if you look at the picture on the right, you can see reflected glare or secondary indirect glare from those pot lights pointing right on the stainless steel surfaces, directed right at the eyes of the workers as well. So very kind of bright spots on those surfaces and reflected back into the eyes of the individuals, and the associated discomfort. So So definitely recognizing a lot of potential hazards with this example here. And, you know, we were brought in to assess, so looking at the lighting levels, looking at the lighting conditions, recognizing these hazards and trying to address them, providing recommendations for control, and then evaluating the impact of those controls after the fact. Also want to just go back to that PDCA component. If we think about, you know, this company or this workplace using that PDCA mentality before switching directly to these LED banks, and the impact of that could have saved them a lot of time, money, and headaches, right? As far as, you know, where this went in the issues that were brought about because of it. And so, you know, if they planned things out, they got a better idea of what they needed, what was required. You know, they sourced a proper vendor who helped them kind of assess the situation and you know, understand their needs as far as quality and as far as production and as far as brightness and this sort of thing. And they went through that PDA cycle. A lot of the headaches could have been avoided there. So just to round us out with an example here. Also, just want to finish up and provide some resources. And so we at WSPS have developed 2 resources, and the next slide will show some QR codes that you can scan to access these. As this is a recorded webinar, you won't be able to click any links. But we developed the one on the importance of proper lighting in industrial environments. And it goes over legislation, assessment and planning, and as well as how to protect and optimize your lighting to prevent some of those hazards, those safety hazards that we talked about, so as far as slips, trips and falls and MSDs, et cetera. As well, there's a checklist that may be helpful for industrial facilities as well. Likely would apply in all environments, but this one is specific for industrial. And it basically just a checklist to go through and to make sure that you're considering all the relevant details when looking at lighting. So if you, these first 2 QR codes that are on the screen, you could pause the screen and scan right now if you'd like, and you can have access to the proper lighting in industrial environments document, as well as the checklist, and just putting our WSPS ergonomics consulting resource for you there as well. And some more links for you if you'd like to pause and access these as well. So providing PSHSA's MSD prevention and ergonomics page, the Ontario Ministry of Labour, Immigration, Training, Skills Development, Workplace Health and Safety page, as well as the ergonomics page from the MLITSD, and a helpful resource from CCOHS on lighting ergonomics as well. And ultimately, if you need help, we can help. Both WSPS and PSHSA are here to help. So feel free to access our websites there. We provide consulting, training, as well as the excellence program from WSIB that we can help with. And so many ways that we can assist with your lighting, ergonomics, or health and safety needs. Some more contacts for you if you need, some phone numbers and our websites here. Feel free to reach out. And just rounding it with some references here if you would like further information. At this time, I would like to just thank our speakers, Steve and Lisa. Thank you very much for joining me, and thank you everyone for tuning in.
Thank you very much.